This is the Concept 1 Level 2 video. Our goals for this lesson are to solve one-step, two-step, and multi-step equations. Our second goal is to explain the steps in solving a one-step, two-step, and multi-step equation. So remember, we're talking about solving, okay? So to solve is to, and this is our first big idea, to isolate the variable. We want to get the variable in the equation alone, okay? So to isolate is to get the variable alone. That is our goal. Okay, so we'll jump into some examples, but before there, we have our next big idea, which is the properties of equality. This is how you get the variable alone, okay? So let's define a property of equality. Property of equality is what you can do to an equation to keep the equation true. So here are a few examples. What if we had 5 equals 5? That is a true statement, a true equation. What if I subtracted 2 on both sides? I would get 3 equals 3. The property of equality that I used here is the addition property of equality. It says you can add or subtract the same thing or the same quantity from each side of an equation, and it'll still be true. Alright, so notice I subtracted, but it's still called the addition property. Well, watch that. Second thing, well, so we already know, what if I added 2 on both sides? It'll be the same situation. I would get 7 equals 7, still true, and that's still the addition property of equality. Alright. Alright, I'm going to delete this so it's not in my way. Alright, so next property of equality. What if I multiply by 2 on both sides? I would get 10 equals 10. What do you think that one's called? That is the multiplication property of equality, which says I can multiply or divide the same thing on both sides, same quantity on quantity on both sides of an equation. Both sides of an equation, and it would still be true. Same thing. Alright, the same thing would happen if I divide it, right? If I divide by the same thing, I will still get a true statement. And that's multiplication property. Okay, 2 other properties we need to talk about. The first one is 0 is a very special number. Think about what makes it special. Well, if I had 2 plus 0, I get 2, right? Or if I had negative 5 plus 0, I still get negative 5. We call this the additive identity. Okay? Because if I add 0 to anything, I get that number back. Or I get the same value. Alright, what about 1? Why is 1 a special number? Because if I multiply anything by 1, right? If I multiply anything by 1, I get that number back. So 2 times 1 is 2, negative 5 times 1 is negative 5. We call that the multiplicative. So 1 is a multiplicative identity. Is 1. So 1 is special. Alright, next thing to talk about, and this is stuff we already do, but we're just adding a technical name to it, so you can be like sounding very smart. So what if I had 3? We're going to learn a new term. This is called, we need to define an additive inverse. Now what is inverse? Opposite, right? Or going backwards, the opposite of something. So basically what I'm asking is, what's the opposite of 3? You should tell me -3. Why? Because 3 plus -3 equals 0. So additive inverse is what you add to a number to get 0. So what would the additive inverse of -2 be? It should be +2, because -2 plus 2 is 0. That's additive inverse. And last one's a little tricky, and we call it the multiplicative inverse. A multiplicative inverse is what? It's what you multiply to a number to get 1. So if I have a 3, and this is where we want to watch our fractions. So if I had 3, 3 times what would give me 1? That's what you want to think about. So 3 times 1/3 gives me 1. Okay, what did I do? Basically, I took 3 and I flipped it. We call that the what? Let's see if you remember. Reciprocal. So when you multiply a number by its reciprocal, you always get 1. So the reciprocal is the multiplicative inverse. All right, let's move on to solving equations. Here are the steps to solving equations. We'll use these for the simple ones, and it may seem like, oh, I already know this, or this is too simple. But we got to start somewhere. So the first step to solving an equation is, 1, you want to assess the situation. Look at where your variable is. What's blocking you from getting your variable along? The second thing, you need a strategy. So we're going to strategize. What can I do? What do I need to do to get rid of the extra stuff so that my variable can be along? 3, we're going to execute our plan. So we're actually going to do it. And the last step, we're going to evaluate. Did it work out? Is my variable along? Did I do something wrong? Did I do something right? So we want to get in the habit of going back and checking our work. All right. So let's use these 4 steps. Actually, I probably should have put it on this side. You could put it on whichever side you like. But let's go ahead and use these steps and jump into some examples. All right. So what makes a one-step equation a one-step equation? You only have 1 step to do before the variable is along. Make sense? Our first example is b plus 4 equals -1. All right, my variable is b. I want b alone. So that means I need to get rid of 4. You see how I assessed the situation. I assess what I need to do. My strategy is, okay, if I need to get rid of 4, 4 is positive, so I need that to go away. So I'm probably going to subtract 4, because if I subtract 4, it would give me 0. So I subtract 4, and I'm going to subtract 4 on both sides. 4 minus 4. So let's go ahead and write down what steps we did here. So we're subtracting 4, so we're using the what? Addition property of equality. I'm going to simplify so I don't have to write it all out, but the addition property of equality. And I get b plus, that becomes 0, equals -5. So if b plus 0 is -5, okay. Well, I can simplify that, right? Because my additive identity tells me that if I add anything by 0, it just equals that thing, right? So b plus 0 is just b, and b equals -5. So I just solved the equation. Last step, you always go back, plug it in, and see if it worked. This is our evaluating. So -5 plus 4 equals -1. That's true because -1 equals -1. All right, second example. I know I said this video was going to be like 5 minutes. I definitely underestimated, but thanks for bearing with me. 2x equals -6. Well, assess. I need to get x by itself. 2 is in my way, so I need to get rid of 2. Strategize. How do I get rid of 2? Well, 2 is multiplying x, so I probably want to do the opposite and divide by 2 on both sides. So I use the multiplication. Oh, goodness. Work with me. Property of equality. So when I divide by 2, that's the multiplication property of equality, even though it's division. Negative 6 divided by 2 is negative 3. And I get 2 over 2. And 2 divided by 2 is just 1, right? Okay. Well, then what else did they say? Well, if I have 1 times x, remember 1 is our special number. That's the multiplicative inverse, which tells me if I multiply anything by 1, I just have whatever that thing is. So 1x is really just x. X equals negative 3. Let's plug it in and make sure we did it right. Yes, because 2 times negative 3 is negative 6. So we're all good. Okay, the next step we're going to do is a 2-step equation. All right, 2-step equations. We're just going to jump into it. 2x minus 5 equals negative 3. Here's your first example. I need x alone, so I need to get rid of 2. And I have a negative 5 I need to get rid of. Okay, so what can I do? Well, if I add 5, I'm going to use the addition property of equality. Negative 5 plus 5 is 0. So as I do these, I'm just going to put addition property of equality. 2x plus 0 equals 2. Well, 2x plus 0 is 2x. That's because this is the additive inverse. And then I'm going to divide by 2 on both sides. I divide it because 2 is multiplying x. So I use the multiplication property. I get 1x equals 1. But 1 times anything is just that thing. So I'm using the multiplicative identity. So x equals 1. Plug it back in. 2 times 1 minus 5 equals negative 3. 2 minus 5 is negative 3. We're all good. All right, let's jump to multi-step equations. All right, multi-step equations is a key thing we want to learn here, and that thing is like terms. So in multi-step, we might have to do multiple things to get variables alone. So let's start with this. So 4a plus 3 minus 2a equals 9. All right, so I'm assessing the situation. I want a by itself. The first thing I notice is I have 2 a's. So we can combine these like terms. They are alike because they both have a's on them. So I'm going to combine them. I'm going to take 4a and I'm going to subtract 2a. Notice how I took the sign with it. So 4 minus 2 is just 2. And we'll tag the a along. 2a plus 3 equals 9. So I combine like terms. I'm going to subtract 3. That's the addition property of equality. This became 0, which is also the additive identity. And then I'm going to divide by 2. A equals 3. All right.